Okay, on this question, we want to figure out the points of inflection of a trigonometric function. And this usually causes some complications because of just uh, our lack of memory, say, of the unit circle. But we're given some function sine of 2x plus 4 sine x, and we're over just one interval, 0 to 2 pi. So we're in a closed interval there. We could look at a nice graph of this and to see where it goes from concave up to concave down. But we're looking in particular the smallest x value that it goes from concave down to concave up. So we're looking for the first time where the second derivative is going to go from negative to positive. So let me get over to my pad of paper here. So I already wrote down the function here. We are first going to figure out where are possible points of inflection by looking at where the second derivative is equal to 0. So let's calculate the first derivative. We have to use the chain rule here. So we get 2 times cosine of 2x. The cosine 2x is the derivative of the outside, and the 2 comes from the derivative of the inside. And the next one is our 4 cosine x. Now, we really don't care about our critical points here. We're just after the second derivative, and we're going to go calculate the second derivative right now. So we're going to take the second derivative. We get a minus 4 sine of 2x minus 4 sine of x. Okay, and we're going to do a nice trig identity here. So this is as an aside. There's really only a few trig identities that I remember. There's 4 of them that I want you to know by heart. And this is one of them that just comes up so often. Sine of 2x is equal to 2 sine x cosine x. We call this a double angle formula because x is the angle, and we're figuring out what sine of the double of that angle. And I'm going to use that fact inside here. So I'm first going to factor out the minus 4. And then I'm going to plug in for sine 2x, that trig identity. So 2 sine x cosine x. Then we have plus sine x. And what's nice about this is we can see that there's a sine x factor that we can now factor out as well. So we're going to go minus 4 times sine x. And then you have 2 cosine x plus 1. Okay, and we see there's possible locations where the second derivative is equal to 0. So here are candidates for points of inflection. So I'm going to put candidates for your points of inflection. Well, we have when sine is equal to 0. So that could be at 0, pi, and 2 pi. And I'm only worrying about values that are inside this interval. Okay. And we also have when cosine of x is equal to minus 1/2. And so if you think about a graph of cosine of x, so some graph like this, and I'm just going to draw, kind of exaggerate it, but suppose here's minus 1/2. It happens twice in the interval from 0 to 2 pi. Okay, our cosine of minus 1/2 will only return that value. And this value right here we can get by actually going 2 pi minus our cosine. I'm going to write that down. It's going to turn out that one's not going to be the important one. But we're going to have our cosine of minus 1/2. And then we also have 2 pi. Well, we actually got to go right there, and this is pi right here. And so you can think of this distance, or you can think this distance right here, it's symmetric about that. So if I go 2 pi minus it, I'll get back to there. It's symmetric about that line. So 2 pi minus our cosine of minus 1/2. Okay. Now all we have to do is determine where the graph of f first goes from being concave up, or sorry, concave down to concave up. So we're trying to look for when does it go from f prime is less than 0 to f prime is greater than 0. We want concave down to concave up. We want that point of inflection. And we have a couple candidates here. We have 0, then comes our cosine of -1/2, then comes pi, then comes this one, then 2 pi. And so we can look at this. We have to look at this function and start to ask ourselves, well, around 0, this is positive, and sine is also, as I increase from 0, it's positive, but it's negative overall. So you can think of, there's a number line here. Okay, so we're going to do our number line starting at 0. The next value that I'm going to be concerned about is arc cosine of -1/2. And the next one is pi. And then we have 2 more. We have pi, we have 2 pi minus arc cosine -1/2. Okay, so in this interval right here, 2 cosine x plus 1 is positive, sine is positive, so that means in the overall sine is negative. So we have f double prime is negative, is concave down. I'm hoping that it changes signs here. And so as cosine of x equals to -1/2 turns, this is going to be 0. And now it's going to become more negative. So this flips to negative, but this is still positive. So it flips signs, and we end up getting inverse cosine of -1/2 as the smallest candidate. Now, of course, if you go back to our answers, and so let me go back and share my screen, we see none of our answers are inverse cosine of -1/2. I'm like, oh no. Okay, we know it's not 0, we know it's not pi. Oh man, it must be one of these. So we have to remind ourselves of our 30, 60, 90 triangle. And let me go back over to my pad of paper here. So remember our 30, 60, 90 triangle. If this is 30 degrees, then this is 1, this is √3, and this is 2, okay? Or if I was on the unit circle and I had the hypotenuse of 1, and this is 30 degrees, then this would be 1/2, this would be √3 over 2. Now, on the unit circle, if we're at -1/2, cosine is the x-coordinate at -1/2, so I'm right here. So at that location, that's going to be 90 plus the 30 is 120 degrees. And so that turns out to be 2 pi over 3 in radians.